since Kyle isn't on yet. So we'll go through the class and get you started.
Because you have to fix it.
And go watch it.
I can fix it. It's broken.
Oh man, hang on just like two seconds. I gotta fix the TV really quick.
No problem.
Come on, hon. Hey, Mike, do we have a book for this class?
Yes, we do. Actually, we have two of them. They're both online. I've got the, if we go up to the course home mod, which I have on screen right now, you'll see Introductory Statistics PDF, which you can download. It's the entire book, 800 some odd pages. Fortunately, we will not be doing that many pages. And then down here, you have a Vital Source ebook. And this is a book that I've used for years, written by a statistician by the name of Triola. And it's a really good book. And I'm going to be using some material out of both, all mod. Your reading assignments generally will come out of both of the books. Let's take a look at first at course media here, which has this first book, the Introductory Statistics, is an open source textbook that we have access to. And then we have some other readings that we can make use of, which is the optional readings here, chapters 1 and in chapter 1, sections 1.3 to 1.6, etc. Those are out of the alternative book, the one that is the ebook that we have instead of the Introductory Statistics PDF. Does that make sense?
Okay. Yep.
And in fact, if you click on these links here, it'll take you directly to the chapter materials that you need out of the PDF, the Introductory Statistics book. We'll also be using the first several chapters of the ebook as well. And a lot of my lecture material will actually come out of that book. Okay?
Okay.
So
yep.
no big books. If you want to print out portions of it, I'd suggest doing that the next time you're at school. Okay?
Yeah. Okay.
All right, so we do have that. So let's take a quick look at what the class will consist of. It will look very familiar to you. We'll have a discussion every week. We'll have some form of in-class activity. Week one's probably isn't going to occur because we won't have any time for it. And an assignment and an assessment. The assignment, I'm going to come up with this one here. Our real topic here at the beginning, let's look at the overview, the learning objectives for this week are to think about statistical thinking, talk about sampling methods, and then look at misleading presentations in graphs. Graphs are used all through statistics and all through presentations, and they can either be very, very concise and accurate, or they can be misleading. One of the major issues in our society, whether it's advertising or politics or anything else, is a misleading use of statistics. And they get away with it for the simple reason that most people don't have a clue what they're looking at. So part of my goal with this class really is to help you have a very critical eye toward somebody who says, well, 75% of people say this. Do they? There's a wonderful example of a toothpaste advertising campaign in the UK. And it was something, it ran into 80% of doctors recommend Colgate. Well, or 80% of dentists recommend Colgate. Well, that sounds pretty good, doesn't it? Especially if you're Colgate. However, what wasn't said was that, yeah, 80% of the dentists did recommend Colgate, along with several others as excellent toothpastes. So again, the absolute number was correct. The way it was presented implied something else entirely. So what we want to really do is be able to look at how we acquire statistical data, how we analyze it, and how we present it. Because, you know, there's an old saying that there are lies, damn lies, in statistics. And that is something that's variously attributed to about 100 different people, but nonetheless, it is something that is true because statistics can be used to tell lies that look like they're backed up by good, solid data, and therefore are believable. And it's done all the time. When I was a kid, I remember a commercial for Chesterfield cigarettes that said more doctors recommend Chesterfield than any other brand. And you know, you look at, of course, these days that couldn't happen. Doctors would have a fit. But that was the kind of advertising. And what does that really mean? Does that mean that 5 doctors recommended that and nobody and no other brand ever got more because the doctors don't smoke? Well, at that time, many of them did, but nonetheless, you don't even have a context for it. So when someone throws a number at you, I want you to be able to look at it and say, okay, what is this really saying? What is the context? And is this valid? And is it being presented in a misleading way? So that's what this first week really is looking at how we think in the field of statistics. Okay, so let's go back and let's take a look at this first assignment, which is about misleading graphs. In every assignment that you have, what you're going to find is a Word doc and a spreadsheet. And let's pull up the first one. If I do that, it ought to come up. There we go. Let's see, it ought to be there. Yep, it ought to come up in a moment. There we go. So it will start off with some questions, and it will tell you to refer initially to the spreadsheet. And let's see if I have the spreadsheet up as well. No, I don't. I'll pull that up in a second. I'm not sharing this, so let me share this. Okay, now you can see it. So it will tell you to go to the spreadsheet and look at and really a short discussion on the benefits of the two ways of presenting the data, and then look at there's in this particular case there are a couple of sets of data, and you'll look at another one on some voting data. And then there's some discussion. You're going to be asked to look for a misleading graph and discuss it. Then we'll talk about sampling techniques. I'll go into that in a little more detail in a little bit here tonight. But we'll look at the various types of sampling methods for doing surveys. And I'm going to have to probably email you guys. Let me make a note. Email some documents that I would normally pass out in class. Okay, I'll do that after we get finished. So we're going to discuss this. So you'll answer a series of questions as well. So that's the way the assignments will work. We'll have varying bits of complexity to them, but that's what you will see each week. So you'll see a Word doc and a spreadsheet. I'll pull up the spreadsheet in a second as well. No, that's not what I want. Okay, so the spreadsheet, we'll pull that one up. Okay. Okay, so here's what the spreadsheet looks like. We've got, in this particular case, we have 2 pages or two sets of data. And this is what we're talking about in terms of the graph. And what we're looking at here is the raw data. And then we have this sort of voting data. And this is obviously some sort of survey as to voters who are Democratic, Republican, or Independent. So you'd graph those out in a way that would show that as a bar graph. And just go ahead and use Excel to do this. So you have 2 ways of submitting the assignment. One is to simply make the documents editable and put your answers in that and then submit those. Or you can create your own document to submit them. You know, I know which one I would choose rather than create something new. I just use what's there. In fact, most of my students in the past have done exactly that, and it's actually very, very good for me to makes my grading a little easier even. But the point is, you do have to submit that, and that would be my suggestion for how to do it. Okay. Let's go back to the assignment. Here we go. So that's what the assignments look like. So you can just, as I say, modify these and submit them at the submission box at the end of the assignment. If you look at this and you see a grading rubric that says 100 points, don't worry about it. It's really the number of points is this number here. And so I'll simply scale up your grade from 100 to 120. So that shouldn't be a problem. Let's see. Let's go back now to the, what I will do is, you can see here on this screen, there's something here called Week 1 Zoom videos. Anytime I have to Zoom a class, I will record it and upload it. That doesn't mean you can miss class, obviously, Jessica. But it does mean that if something comes up, you can get the information. And so that, and then you'll be able, when there's something in there, you'll be able to see it. Let's look at the initial discussion here, and it's about surveys. And that's where we're starting off this class, is talking about methods of taking surveys. Surveys are a very important marketing tool. I'm sure you've heard that from John. But designing surveys is the key to their success. I have seen surveys that were very poorly designed and gave very, very clear, misleading results because the questions weren't properly asked, and the survey participants weren't properly chosen. So there are a lot of things that go into that. And when you do that, think about, in this particular discussion here, you can choose one of these three scenarios, only one. So you've got a topic to find out which item is most popular in your store, opinions on healthcare provided during an office visit, or a software package that's best for an application in the company. So prepare your, when you're putting this together, the prompt is to discuss the survey, the questions, the purpose, and the audience, and then the sampling technique that would be best. And we'll go into sampling techniques in a little bit. Okay? Make sense so far? Okay. And you'll see that I've already posted my initial post here. There's only 2 of you in the class, so it will be hard for you to do 2 responses. So make sure you respond to each other. I will also be responding to you. So if you want to respond to me, because I might actually pose a question or 2 in my response, please do. Okay. And it's the usual rules. Okay. Wednesday night, you're supposed to get your first post done, and then by the weekend, end of the weekend, get your responses. So it's the usual rules for that. This is a 300 level class. Okay, so our expectation of you guys is a little higher than the lower level classes. We're looking for a minimum of 200 words and 2 citations. Okay, so it's a little bit more work. We're expecting a little more out of the 2 of you. All right, so let's go here. And then I want to switch over to sort of the meat of this week's class. You still will need to read the chapters in both the PDF, and I would suggest you at least scan the chapters in the ebook because there's a lot of material in them. I will also, in the course of the class, be pulling some things from other sources that I have about statistics. So there will be some things that you won't have in the textbook that will appear. So let's go to the textbook. I have pulled up the textbook by clicking on Vital Source ebook. And then it'll do the usual. It'll open up it'll tell you to open a different tab to get the book. So this is what, let's go back to the beginning. This is what this book looks like. Elementary Statistics by Triola. This is a custom edition for us. So it really has basically everything we are going to be discussing in this mod. Graphing, statistics, descriptive statistics, probabilities, and probability distributions. Those will be a lot easier. Some of these later concepts like probability distributions are going to be much easier to handle in the classroom. So I'm looking forward to being able to meet with you guys. So let's just take a look. If we go here and take a look at a survey, and this was a survey about just asking simple yes or no. Have you ever been hit by a computer virus? And so the raw data were yes, 106,685 people responded yes, and 63,378 responded no. This is a huge survey. Most surveys are designed to be handled and acquiring data from only about 1,000 or 2,000 people, subjects. But there are ways of getting these larger databases or cohorts of data. So anyway, this is one representation of the data. And it looks like the yeses are about 3 times the no's. Well, if we look at the raw data, the yeses are only about 60% higher. So something's wrong here with the way this is presented. This is a real common trick in statistics and in people who use these kinds of data. Note that they start from a base here of 40,000 and go to 120,000 instead of starting at 0. Okay, so let's take go to the next page of this book. We have this misleading graph. The vertical scale does not start at 0. So we really, it looks like there's an awful lot more. Politicians do this a lot. Advertisers do this a lot to make the data look very, very different visually, because most people are visual. They don't look at numbers. They will look at the visual of the presentation, and that's how they form their impressions. Okay, and this also, we look at the sampling method. In this particular case, the sampling method was actually responses from an America Online survey of internet users. The survey was posted on their website, and the internet users decided whether or not to respond. This is called voluntary response. And voluntary response, we find that a voluntary response is skewed in the direction of people who have an interest in the topic or have a very strong opinion about the topic. When it's a voluntary response, most people are not going to respond. I'm guilty of that. I get, whenever I am online or on the phone with someone or online, I get the question, would you like to fill out a little survey after this conversation? My answer is 100% no. I can't be bothered. It's all voluntary. So I'm skewing the data just by that. So what we have to do, what we're looking for is a sampling technique that gives us a really good cross-section sample of the population that we're trying to survey. Preferably by a random methodology, but there are many ways of doing that. So we're going to go down here and take a look at a couple of other things. Let's look at some definitions. I'll have a bunch of definitions for you guys when we meet next week. Data. When we talk of data, they are observations or measurements or other information that we get in our investigation. And that can be numerical, it can be non-numerical, it can be any kind of parameter that we're attempting to measure. And then statistics itself is both the science of planning these studies and obtaining the data, and then the analysis, interpretation, and conclusions and presentations that we come up with at the end. So statistics as a science is one thing, the process of statistics is another. Here we're going to be going into a lot of the processes. A population is the collection of our measurements that are being considered. And we have two ways of looking at that population. If we're looking at, let's see, nowadays we're hearing an awful lot of political polling being done with all the stuff going on in the wacky world of Washington. And so, but everybody is not responding. What these guys do is very carefully choose a random sample by a number of different methods of people that are likely to vote, usually, and look at them. They take a subset of the population of likely voters, and a subset is called a sample. A census is when you actually take your data from every member of the population. And we're going to go through a census next year, because 2020 is going to be a year when we do our decennial census as required by the Constitution. And in that process, we will make every effort, and believe me, they work hard at this. They'll make every effort to talk to every household in the nation. And this is because, and it's important because there's trillions of US bucks involved in that in terms of government contracts and aid and cost sharing and revenue sharing arrangements. And more importantly, the distribution of our members of Congress. The House of Representatives is based on these data. And so every time we do a census, we find that the population of the country has shifted. Some states are going to lose a representative, although they can't go below one, and other states are going to gain them. So we've been watching that happen. I mean, in the last, well, during my lifetime, population has shifted south in this country to warmer climates. So the growing states are the southern tier of states: California, Arizona, less so New Mexico, although it's trying, and Texas, Florida, obviously, Georgia. The southern tier of states have been growing, and so they have being able to have more representation in the House of Representatives. And we find this out by doing this decennial census. So they go through that process. But for the most part, you're going to look at a sample. Let's just say you wanted to know you wanted to know how College America students were how satisfied they were with their program. Just a simple question, right? Our student count is low enough that you could talk to every single student at the school. That would be a census, because the population is College America students. Now, if you were interested in learning something a little different, which is how grads that had been working for, say, 3 years felt the program had helped them in getting their career, that would be different. You'd have a bigger number. You would probably not be able to contact them all, simply because some of them would not be available for one reason or another. So you would take a smaller group. You might take, you might be looking to contact, say, 10% of the graduates that had graduated, say, in the last 15 years, and ask that question to them. You might, and so that would be a smaller number. And you would use that data. The purpose of doing these samples is to be able to generalize the results to the entire population. And so, so that's really the major difference here between census and sample. And in some ways, a population is, if you look at the population as a whole, that's your basis. And the population in the samples that I gave you were 1, current students, and 2, graduates within the last 15 years. So each of those are a different population, but they fit the statistical definition of population. There is a process of conducting the study, and you're going to be looking at that for your discussion, obviously, which is to prepare, meaning define your population, define your questions, define what you're trying to find out, analyze, get the data, analyze, and then draw conclusions. So we're going to look at some other characteristics of that. So when we're looking at statistics, we're looking at what do the data mean? What's the goal of the story? You really, collecting data to collect data is a waste of time, in my opinion. Some people just like to collect data, but there has to be a purpose, the goal. Why are you doing this? Are they, the source of the data? Are they going to be a group that has a particular interest, or are you going to try and get a broad base of people in your method? So how do we choose them? This is called the sampling method. We want to collect them in a way that's unbiased, in a way that and look at, that would be our preference, but we need to look, one of the things that you'll see in any sort of statistical study that is being properly presented is how did we choose our participants? And so what you want to be is you want to find a way to make that as unbiased as possible, because biased data are worthless. They're always, when you have a setup that looks like it's giving you biased data, you have to ask if it was designed with a goal in mind, which was anything other than to find out the truth, which is, get the survey from a broad population. And then you want to accumulate the data, explore it, graph it out, explore it. You want to look at things like outliers, numbers that are very, very far away from everything else. There's a beautiful study of NCAA head football coaches that was conducted, I don't know how many years ago now. But the vast majority of these football coaches were being paid a very considerable salary, $300,000 to $500,000 a year. But then in the data, there was one at 1.6 million a year and another one at 2.5 million a year. So these we call outliers. They are extremely far away from the bulk of the data. So that means that we, next week, we'll be talking about measures of center, which basically are, what is the data centered on? That means that our choice of how we summarize the data and how we present it are going to change because the outliers have an effect on that data. For example, if you took the simple average of those 20 or 30 coaches that were in that study, it would be shifted to the high end because of the two real high outliers. So there are other ways of looking at it. So we looked at we look at all of this, and we also want to know, since you can't force people to participate, there are always going to be people that you randomly choose who say no. So what you want to do is keep a record that you had this many people refuse to respond, because that too can affect the results. And then we use various statistical methods that basically we're going to be using Excel a lot in this class, because the statistical functions we need are almost all there. And the ones that aren't are simple two-component calculations, so they're not a big deal. But do they have statistical significance? There's a difference. This is one thing that I want to touch on. Statistical significance means that if you analyze the data, your conclusion is real, and it statistically can be backed up by numbers. But are they practical? There's a wonderful study of the, I think it was the Atkins diet, in which there was this publication that said that people staying on the Atkins diet for a year lost, on average, something like 5 pounds or 5.6 pounds. Now that's, most people would say losing 5.6 pounds. I mean, and statistically that was real. I mean, it was, the numbers supported it. But did it matter? I mean, who's going to be on a rather restrictive diet for a year to lose 5 pounds? Not too many people. So it is of no practical value. So that's what we really want to look at, and that is sort of one of my many questions that I ask when I see statistical studies, which can be summarized as, okay, so what? What does this really mean? Is this important? Where we see it is in the data on smoking, for instance. After many years of statistical data collection, it became clear that smoking and heart attacks and lung cancer were related. And, is that of practical significance? Yeah, nobody really wants to have an early heart attack or lung cancer. So that's important. But 5 pounds on the Atkins diet in a year? I don't think so. My opinion. Okay, so let's see. I want to back up here. What's the study? Okay, so here's an interesting bit of information looking at IQs and brain volumes. Now, setting aside the fact that there are a lot of problems with measuring IQ, and the methods have come under strong attack in recent years because there are so many ways to measure intelligence. And, you know, for instance, I guarantee you that my automobile mechanic doesn't know near as much about chemistry as I do. And I guarantee you that I don't know near as much about repairing cars as my auto mechanic. So his intelligence is in a very practical way for him, and it's at least as much intelligence as I have, maybe more, because he knows about this stuff, and you know, and he also is able to put it to use in a very practical way. So again, with the old IQ test, just measuring facts. Can you remember when the Battle of Tours was, or some nonsense like that? And all it is your memory for facts and figures rather than your ability to solve problems, which is really, to me, the best intelligence. But let's take a look. Somebody said, well, people who are smarter must have a larger brain. Now, you might think that's ridiculous, and you might say, well, that's at least a logical start. Maybe it's true. So here's what they found. We've got, they measured IQ using some standard measurement tool. And then they measured brain volume by basically doing skull volume and then subtracting the volume of bone and stuff. So brain volume for this guy with an IQ of 96. And remember, an IQ of 100 is average. Anything over 100 is better than average. Anything less is less than average. For whatever that's worth. But the guy with a 96 had a brain volume of 1,005. The guy with an 87 had a brain volume of 1,035.
Can you fix my TV again, please?
Hang on.
Okay.
Bubble Guppies is playing. Go watch Bubble Guppies for a minute. You want to watch Bubble Guppies?
No, I want to watch the dinosaur TV.
The dinosaurs aren't on, hon. Wait for Mom to finish her. I'll be done in just a little bit, I swear. And then we can watch a movie or something. Go watch Bubble Guppies. Sorry, Mike.
No problem. No problem. So if you look at this table, the numbers are all over the place. Okay. So let's take a look. This is actually a study that was published looking at this information. So the sampling method for that data, the subjects were recruited by the researchers and were paid. All of them were within a relatively narrow range of age, although, again, IQ is dependent on age as well. At least a high school education and, you know, a medical history that cleared them of having any neurological problems. So in this case, the sampling method appears to be fairly sound. There's nothing wrong with paying people to participate, although that might make people participate who might not otherwise. But if your other methods of identifying subjects are not a problem, and everyone is paid, that's fine. So let's look. At in this case, it looked pretty random. So let's look at what a non-random process, this voluntary response. Here's some examples: internet polls, mail-in polls, telephone call-in, or kind of things where, if you have an opinion on this, give me a call. Radio hosts do this a lot to try and sway public opinion. So these are all very biased populations because only people with an interest in the topic or a strong opinion are going to participate. And so they, the only things that we can really do is draw a conclusion about the people who participate. We cannot scale those up to the larger population because we don't know about the people who either have a very minor opinion or none whatsoever. So here's a good example of a mistake that was made in the 1936 and 48 presidential elections. Literary Digest conducted a poll. They sent out 10 million ballots, and they actually received 2.3 million responses. And that the result was that, or the end result of that poll was that Alf Landon was going to beat Franklin Roosevelt for the presidency. Well, we know that didn't happen. And in fact, Gallup had used a different method of choosing, and he too had a huge poll. 50,000 people is big. Okay. 50,000 people is a big poll, but he correctly predicted that Roosevelt won. So the problem was that the
sorry.
Yeah. Sorry.
But I have to see my teeth.
Sorry, he tried to run off with markers. I was just making sure he wasn't running off.
No problem.
Go
Anyway,
ahead,
the
continue.
Literary Digest sample was not a broad measure of the population at the time. 1936 was the height of the Depression, and or the Depression was starting to ease up. At that point, the Literary Digest, however, went to rich people, people who could afford to not only buy the magazine but owned cars and used telephones. So these were wealthy, and the majority of them were Republicans. So it was a voluntary response sample as well. The Gallup poll used a different approach, which was based on looking at demographic factors. He was looking at different socioeconomic classes of people and broadly around the country as well. Gallup also screwed up in 1948 by quitting his poll too soon. He didn't get enough data, and he is the one who predicted that Truman was going to lose, which of course didn't happen. So we have we have lots of ways. There's several examples here of voluntary response and why they don't really work. So we have to look at how we get our subjects. I talked a little about statistical significance. Let's just take a look here if we look at 100 random births and find 98 girls, this is statistically significant, because we know that approximately half of the babies born are female, and in fact, just slightly over 50%. I used to work with a neonatologist who'd tell me that all of us were conceived female, and somewhat less than half of us degenerated into males. So that's not, it's not, if that were the case, if that were the result, then this would be significant, because it's not likely to happen randomly, since we're talking about 50-50 chance for every single birth. However, if we had 52 out of 100, that would be insignificant, because there's no real difference there, because that could easily occur. Okay.
Just one thing.
We talked about practical significance. So when we're looking at analyzing the data, we're going to talk about a number of different things. We need to look at the statement here. We'll get into correlation later, but correlation, just because two things happen at the same time, doesn't mean that one caused the other. Okay. There are lots of things. There's a wonderful study published a number of years ago relating the price of a slice of pizza in New York City to Subway fare. And if you plotted the increases of slices of pizza and the price of Subway fare over time, they both went up together. Now, clearly, pizza doesn't cause Subway fares to rise. And Subway fares don't cause the price of a slice of pizza to rise. So there's something else going on. So just because two things happen, and this is another way statistics get misused, just because two things happen at the same time, that means that you should look for other factors that cause it. In the case of the pizza slice and the Subway fare, that's an easy one. It's really related directly to inflation. So we can see that, and you can understand why those two things would be there. So we need to be you need to be also how you collect the data. I like this example. If you're studying, say, an exercise program as a means of losing weight, you don't want people just to report the results. You want to measure them yourself, because not that people are going to actually deliberately lie, but they're likely to give you their best estimate, or where they want to be, or just change things. They won't be really accurate. So how you collect your data is also important. Samples need to be big enough. Again, this lovely study here that's listed here in small samples, the Children's Defense Fund did itself no favors by reporting that among secondary school students suspended in one region, 67% were suspended at least 3 times. They based that on 3 students. So, and that just is not enough to draw any conclusions. Sample size is important. If they had added a 4th student, it's unlikely that they would have maintained that. If they, there's a lot of things. We should also be careful about loading the questions. There's an old joke about a lawyer who was trying to trying to win a case, and he asked a question, and it was a spousal abuse case, and the question he asked was, do you beat your wife? No. When did you stop beating your wife? Well, you can't answer that question in a way that is going to not imply that you beat your wife. Those are the kinds of questions you want to avoid, or the answer has to be very clear. And so these intentionally worded questions can be pretty subtle. This particular example was yes, the rates of yes responses to two distinctly different wordings of a question. Should presidents have the line item veto to eliminate waste? 97% of the respondents said yes. But if you ask a different question, should the president have the line item veto or not, only 57% said yes. What you did was take out a loaded example of a use. Most of us, when we look at bills, see that there's completely unrelated crap in them. And it would be nice for a president to be able to say, no, clause 12, we're out. But that's not the way it's run. Okay. Also, you can change it with the order of questions. You can do this. There's also, you remember from your study of algebra, the difference between accuracy and precision in a number? Okay, that's probably not something you've thought about since algebra. Precision is based on the level of measurement that you can make. So if someone says there are about 2,100 people living in this building, the precision sounds like it's really there, but about 2,100 means that we have the only part that's really accurate is the 21 part. So we have a number that's precise to only what we call two significant digits. If someone said there are 2,132 people living in this building, if you knew that number to be the correct number, then it would be also accurate and precise. So what we want to do is remember that we have to be careful about looking at numbers and being impressed with numbers like this one here. This is obviously an old figure, 241,472,385 adults in the United States. Okay. A lot of people assume that because you've just given them a string of 9 digits, it must be accurate. In reality, it isn't, because it's constantly changing. People move into adulthood, they die, they leave the country, whatever. That number changes constantly. So we're better off rounding these things off to something that's that makes it clear that you're not trying to basically baffle them with your BS by giving a big number. Okay, percentages are another goodie. You've probably heard people say, I want you to give 110%. Well, I'm sorry, that's impossible. You can only give 100%. And your 100% might vary day to day. So these are ways that people use statistical sounding numbers. And this example of the airline saying that they had improved their rate of lost baggage in over some period of time by 100%, that's impossible. It would have had to go to zero. And anyone who thinks that there is an airline that has zero lost luggage, got a bridge to sell you in Brooklyn, because it just doesn't happen. So these are numbers that we need to be careful how we present them. I'm not going to go into to all of this basic math. So, all right, so let's keep running quickly. I'd like to go into some other sampling techniques and some other definitions. A parameter is something that describes a characteristic of a population. In terms of that, perhaps we can look at the idea of a parameter is something that is common to everyone in a population. If you were looking at, say, all students at College America, a parameter of that population would be current students. That would be one of your questions. Are you a current student? Yes or no? Okay. So that parameter, that's of the population. If we were looking at the example of people who felt that their education had helped them in their career, and we were looking at 15 years worth of graduates, and taking a sample, say 10% of those, then a question like, are you working, would be a statistic for that sample. Okay, so it's a kind of an abstract kind of meaning, but what it is that a parameter is something that is there for everyone in the population, and a statistic is some characteristic that is for your sample. So just keep that in mind, because you'll see some questions about that. So again, the population size of the adults of the United States, that big number, is a parameter because it's based on the entire population. A sample size of 2,320 is a statistic because it is based on that sample, not on the entire population. We want to, looking at this particular one, I don't know when this was done, looking at these respondents that had 5% of them said they had a body piercing. That 5% is a statistic because it's only based on the sample, not necessarily on the entire population. We have quantitative and qualitative data. He also calls it categorical. Quantitative is obviously numbers which represent actual counts or measurements. There are numbers that are not counts or measurements. Two really strong examples of that are Social Security numbers. You can't add and subtract them. And there's no Social Security number that is better than another Social Security number. Or zip codes. They're merely descriptors. They are labels. Okay, so they're not numbers. You can't add and subtract. There is no difference between the zip code where I live in Loveland of 80538 and the zip code of the school, which is 80525. No difference between them. You can't subtract them and say, we're 13 better than you. Can't do that. So there are lots of them. Another good example is the jersey numbers on football players. They're just labels. So just because it's a number doesn't mean it's quantitative. Anything else, names, labels, colors, foods, whatever thing you're looking at, these are all qualitative data. or categorical as he calls them. In this class, we're going to use them qualitative because that's what I learned. Years of in years of looking at statistics. Okay, so good examples. Quantitative data is ages. Categorical data like political party affiliations. These are labels. They're just categorical information. And then we talk about the categorical data as numbers. And we're talking about jerseys of football players here, but as I said, there are others. If we are looking at quantitative data, we need to say what we're measuring. So in the case of this quantitative data, ages and years of survey respondents, each one we would say was 23 years old or 37 years old or whatever. We make sure that we are looking at this and recording that. If we were doing some developing a database of the range of, say, heights of children, we may, for toddlers, anybody under about 2 years, we might measure that age in months. But we need to specify whatever it is: dollars, seconds, weight in kilograms, degrees Fahrenheit, whatever. So further, we can look at discrete and continuous data. Discrete data are numbers that basically can be counted, such as looking at the number. Discrete data would be, again, the ages of the adults in your study, because we measure it in discrete year units. Then we have continuous data, continuous numerical data. Infinitely many possible quantitative values. And that is things like birth weight of babies. Each baby has a definite birth weight, but the range, the type of data, it can be anything along a wide range. So there are differences, but nonetheless, that's a continuous range. We don't expect countable numbers in this. So here's some examples. Discrete data. There also is, we look at countable. There are finite numbers that will arise. So the number of eggs a hens lay in what week, these are discrete, they're finite numbers, 5, 7, whatever, 9 maybe, that result from being able to actually physically count each one. Discrete data of an infinite type is you can count the number of rolls of a die. I mean, theoretically, you could roll a die and not ever get a 2 for some strange reason. Not likely, but it's theoretically possible. And so there are an infinite number of data points that you can get, but you can still count the rolls as you proceed. So these are countable. Continuous data is a number that can be anywhere in a range. During the example here, a cow might yield anywhere between 0 and 7,000 liters of milk in a year. So we cannot, and it can be anywhere in that range, because of course It can be any small increment. So those are continuous types of data. We have measurements, types of measurements. Because we want to be sure that that we look at the type of data that we have, because when we do the analysis, there are some methods that don't work for some. Example, we can't take an average social security number, but what we call nominal data is data that consists of names, labels, or categories that cannot be arranged in an ordering scheme, low to high. Names. We can come up with some, we can alphabetize them, we can put them in an order, but there's no natural order of these things. The nominal level data, yes, no, and undecided. That's really you got three possible answers. There is no difference between yes, no, or undecided. So political party, same thing. These are all nominal data. There's no real ordering or significance that allows us to use them for calculations. Sometimes when we see these on a scale, you see this every mod, you see this on a scale of 1 to 10, rate the following about your class. So, those are really nominal. We calculate them up and figure out something, but there's very little computational difference in that. Then we have ordinal, which are data that can be arranged in some order, but differences are meaningless. Course grades are a good example. We do have A, B, C, D, and F as grades, and we can arrange them in order, but we can't determine any difference. I mean, we can't subtract a B from an A, for instance, or the other way around. Ranking. When we order ranking of favorites, that too is not really. It's in order, but what's the difference? If you're ranking your favorite colors, there's no difference between blue and red. So we can, but they can be arranged in order if we follow the rainbow. So ordinal data talk about relative comparisons. Interval measurements are such that they can be arranged in order, and differences can be found between the values, but there's no natural zero starting point at which none is present. A good example of this is given on this page, temperatures. We talk about the temperature being 40 degrees or 90. There's definitely a difference. We know that their difference is 50 degrees, but there's really no natural starting point. Because 0 Fahrenheit is just an arbitrary number and does not represent a point at which there is no heat. Same with years. We can arrange a year, 1919 and 2019 obviously are different. There's a 100-year difference, but there is no year 0. So this is what makes them interval data. There is no 0 starting point. Then we have ratio. These can be found, they're meaningful. There is a natural 0 starting point. Class times. We can have difference in class times for different classes. And there is a 0 because that's called no class. So there is a 0 point, but a 100-minute class is twice as long as a 50-minute class. Or, a 75-minute class is 1.5 times the length of a 50-minute class. We look at this. This is a table here. This is on page, 20 of the Triola book. This ratio is ratio, interval, ordinal, and nominal. This little table can help you and give you some ideas. Okay. So again, I like this eye color. There's no order. It's an order of preference maybe, but there's no order. So let's keep running through these. Collecting. We have 2 different kinds of studies. Observational, which is we simply observe and measure without attempting to change anything. That's an observational study. In an experiment, we apply some treatment, or in medicine, we do this when we're developing drugs. We apply a treatment and see what the outcome is. Or we maybe raise the temperature and see what the outcome is, a series of experiments. So we actually do something to the subject. Okay, so there is a very great difference from simply observation and you're looking at something and measuring something. The idea of that I mentioned earlier of taking children up to 2 years of age and measuring their height at specific age points in their development, that is an observational study. We haven't done anything to affect their height. Okay. So you'll see some questions about observation and experiment. Okay. Let's keep going. Now we get to sampling techniques. Simple random sample. This is when we select, if we have, we want a sample of, they're using the word N here, but a specific number of subjects in such a way that it's possible that every possible sample of the same size N has a chance of being chosen. Meaning that if we are, if you're doing your study on, let's just say you're studying something like looking at, there's an experiment that was done years ago about freshmen in college. There's a phenomenon known as the freshman year weight gain. And so in this particular case, what you want to do is find out if it's true that freshmen gain weight in their first year in college. And so the study was carried out in a way that they recruited college freshmen such that it was completely random as to who was chosen to participate in this. And the way that that was done is that to follow a simple random sample, it means that if they wanted 1,000 freshmen out of, say, 100,000 in the country, the way that the method of choosing would everyone would have the same probability of being included in the sample at the same time. So it's just so that's how we look at that. the sample is chosen so that it is likely that everyone has the same chance of being chosen in the group. So so we'll look to some other sampling methods. So we have some computer programs that are often used to generate random things like mailing addresses and telephone numbers. So we have, and that can, to choose people to participate. We talked about simple random. Systematic is sort of like choosing every fifth person. If you were doing a survey at the door of, say, King Soopers, you might choose every fifth person who walked in and see if you could get them to participate. So this is called systematic. Convenience is basically family members, friends, just anybody that happens to come along. And this is where a lot of samples this is how a lot of sampling is done here in Loveland at election time. You might, walking into the Chilson Center here in Loveland, where we go for exercise. Walking in, there are people standing out there asking us as we go by if we would want to, if we would please participate. And the answer is, some people do, some of us don't. So that's convenience sampling. And again, you're likely to only get people that are feeling particularly wanting to be a part of it. Stratified is we subdivide the population by some means and into different subgroups, at least two, and then so the subjects within the same subgroup can share the same characteristics. They use gender and age bracket here, but you look at this as a way of getting stratified sample of different groups, and then draw a random sample from each of those strata, those levels. Cluster sampling is a bit more complicated. Somehow or another, you divide the population into sections, clusters, and then randomly select some clusters, and then choose all of the members. Here in, if you were doing a poll in a city, you may try either. I live in Loveland, so we've got about 100,000 people, 80,000 people that live here in Loveland. So if I wanted to do a poll, I wouldn't want to poll everybody in the city, but I might divide it into, say, men and women, and then age groups in each of those, and create a whole several different groupings, and then draw samples from each of those groups to try and get the information that I want. Or I could look at it as and divide the city into neighborhoods by some definition, some common definition, trying to get people within geographic areas, and then randomly choose neighborhoods and go door to door. So these would be the difference between stratified and cluster. Okay. All right, so we have those. We have cross-sectional studies. types of studies that we do. Cross-sectional is something that we collect at one time period, at one time. So if I were wanting to determine what the average hourly salary was at say Hewlett Packard, I would the question would be would I look at, you know, say as of June 1st, one specific date, or would I collect data over time? So a cross-sectional study would be taking that June 1st date. What is it right now? What's the distribution? Retrospective, we go back in time through a variety of methods. We can go back and examine records and interviews and truth and other things. And prospective studies are usually taken over time, starting at a certain point with a group of people, a group of subjects that you follow and collect the data. The most famous in medicine is the Framingham Heart Study, which was started, I don't know, probably 60 years ago now, maybe longer, in Framingham, Massachusetts, to collect data on lifestyle and then disease. And looking at specifically, started specifically at heart disease, but now they're looking much more broadly. But they're watching over time as people's health is influenced by their lifestyle. So that's a prospective study. We'll talk about blinding another time. Certain kinds of studies need to be blinded to take bias out of it, and we'll talk about that. What we want to do is design our experiment to wait and get clear answers. In other words, that you don't find yourself confused or confounded by having too many factors in a study. Okay. So there's several things here that talk about bad experimental design. Looking in medicine, you would not treat all women subjects and give men a placebo. Because in actuality, women and men respond differently to different drugs. And you would not, if you were looking at a drug to treat, say, menopause in women, you wouldn't give men a placebo. They wouldn't be a good group to study, although men have menopause too, not the same thing. You wouldn't do that sort of thing. So, so the confounding issue here would be, is there a sex difference in the response? Okay, completely randomized, you would select subjects of both genders to give a drug, and of both genders to give placebo as well. So another way of doing this is matched pairs. Basically looking at the same subject before and after. So the matched pairs are the same person, but you're doing a before and after study. We do this basically, most of clinical trials in medicine use this kind of a design. They don't call it that, but they are looking at a patient before going into this experimental treatment and then looking afterwards. So that's a matched pair. Randomized block is to again block out by some characteristic, in this case men and women in different blocks, but then randomly treat or include both in there. So the designs are such that we want to remove as many issues that may confuse as we can. Okay, let's keep on running. All right. So let's quickly go to chapter 2 and look at graphing. Okay. Here is a whole pile of data. You may want to look at it separately, but we're looking at, again, we're going back to IQ, but we're looking at IQ of scores of groups of people with usually children with low lead exposure and low lead levels in their blood, and another group high levels. This was an important study that led us to understand the effects of lead poisoning on cognitive development in kids. But we want to look at how we analyze the data, how we plot it out. One of those is to look at what we call a frequency distribution. And I'm going to ask you to read this material because I don't want to keep this going on forever because I know you have a child to take care of. But we can look at what we call frequency distribution, which is to set bands of the data and just tell how many people fall into it. So if we go back to the low lead group, the total number of participants was 78. 2 of those had an IQ somewhere between 50 and 69, 33 between 70 and 89, 90 between 90 and 100, or 35 between 90 and 109, and then smaller amounts above that. So we actually set these up in these classes, and we can construct a frequency diagram. Let me see if we can get over here to what one of those might look like. Oh, they're not showing me what I want to see. Okay. So so this is grouping the data. We can then present this. Let's keep going. We ought to get there. So we can do this in what we call a histogram. A histogram is these bar graphs where the bars are butted up against each other. So these ranges down here are those class boundaries we talked about. And this happens to be, again, that particular low lead group. So we can see much more visually that that there is this this number, and this is the frequency. Here is the number. So we've got 2 people in this particular band. We've got 33 and 35. And then we have 7 and 1 in these other bands. So this gives us a visual of what the data look like and how they're distributed. This relative frequency is just a percentage. So each of these is a percentage. I said there were 78 total data points in this. So this number here would be 2/78, or a bit over 3%, or a bit under 3% of the data. So all we've done is convert this to data by dividing the number of data points in this band by the total number of data points. Okay. Then we can look at this and we can say, you've all heard the term normal distribution or bell-shaped curve. This can be seen as sort of like a bell-shaped curve. Clearly, you know, the top of it is a little bit into this band because there are more data points there. But you can see that we can represent this. And the idea is that here we have 78. The idea is that if we had, say, 780, this still would look sort of like this, because we have our sample before. It might not look exactly because the difference between 778 and 780 is pretty big, but nonetheless, this is what we start looking at. And then we look at how the distributions, we can have the different values. We can have lots of other distribution shapes, data that this is sort of Bell, and this again is a big data set, lots and lots of numbers here. The frequency in here is looks to be about 530 for the tall one. So you can imagine there's a lot of data points, which makes this look pretty pretty smooth. And our normal distribution looks a lot like our bell-shaped curve. Is it perfect? No. We have uniform distribution. Everything is pretty much the same. Over here, we can have skewed data, meaning that there is more data to the right and it trails off to the left, or more data to the left and it trails off to the right, or over here where there's more data to the right and it trails up from the left, because we by standard behavior we read from right to left. So we can have different ways that the data will distribute. Not going to get into too much of this at the moment. Want to see if there's anything else that's critical. Scatter plots. Scatter plots are simply taking the data and plotting it. In this particular case, there was a question as to whether arm circumference and waist circumference in males were related. Okay, so what they've done is take each of these points represents one person and represents their arm circumference and their waist circumference in centimeters. Okay, so you can see, just looking at it, you're going to say to yourself, well, it looks sort of like they're related. Makes some sense. Is it perfect? No. In fact, if we look here, we've got this person, we've got three people here with about the same 82 centimeter waist circumference who have pretty different arm circumferences. This looks to be about 27, 31, 35. So there's fairly some differences here. And it's not perfect. There are places where it doesn't work out, but overall, they sort of seem related. Using weight and pulse rate in males, we get this as a scatter plot. We look at this and we say, nah, there's not much relation here. So we don't expect to see that there's any particular, we call it a trend. We've got numbers all over the place. We've got this person over here with about a 75 pulse or 75 kilo weight and a pulse rate of 90 beats per minute. And we've got this person over here with about an 83 kilo weight and a pulse rate of 45. So we've got this scattered. So this is a way of an initial way, a lot of times that we collect data, numerical type data that we can plot like this, and just see. Just look and see if we think there is a trend. Now remember, I said just because they go together doesn't mean they're related, or they cause it. But that's where we are with that. Clusters. This is an interesting little thing. They changed the composition of pennies in 1983 or 1984 actually, or 83. And so the weights of pennies plotted by year, the average weight of pennies somehow or another, we can see that they used to be heavier. Okay, they aren't anymore. Okay. We can look at time series. The Dow Jones average is a good example of a time series. The the high of the Dow Jones average in each year from 1980 to 2005, 6, 7, 8, 9, 2010. So we can see that that's watching a change over time. We have what we call a dot plot, which is simply another way of doing the frequency. What we do is we have a scale. Here's going back to the low lead IQ stuff. We have these scores. All we've done is this is the number of data points at each IQ. Okay, so we've measured this, and so what we're seeing here, instead of bands, there is a data point here for every single measurement. So we've got IQs of 80. There were 3 of them. Of 84, it looks like there's 1 of them. Of 95, there's a bunch, and so forth. And then way out here at 141, there's 1. And down here at 50, there's 1. So this is just another way of looking at that distribution and seeing in a sort of a flatter manner the normal distribution here, the distribution of the data. We won't go into stem and leaf for now. Bar graphs, you've seen these many a time. Median income by gender. This is one that always makes my female patients or female students angry. And me too, because it affects my wife and my daughter, and it actually affects everyone in reality. But if we take a look at the median income by gender, this is a bar graph. We're comparing men and women, so we have different colors, and we're looking at decades. So instead of but you can see that although both go up, it's pretty clear that, you know, that women are gaining a little bit, but not near enough. Okay. A Pareto chart is a little different. What we've done is look at asking questions. Okay, in this case, what contributes most to happiness? So we take the one with the highest value and keep it going down. Okay. Pie charts are another way. You're all familiar with that. Pie charts have some very good uses. They also have some ways that they can become confusing. If you are looking at this compared to the Pareto, you're going to see, yeah, way up here for family and partner contributing to the happiness, and here too. Usually you want everything to go clockwise from highest to lowest. And you don't want too many parameters. You put too many in and you've got a mess. Another method is the frequency polygon. All this does is take a line and start with a 0 frequency and then going to the midpoint of the first first group in the frequency, and just totaling it out this way. Another way of looking at frequency. Okay, and this is called an ogive, and all we've done is take the cumulative scores, the cumulative frequencies for the data. Okay. Now let's take a look at how this can be misleading. If we take a look at this figure here, we're looking at highway fuel consumption for 3 cars, a Civic, an Aveo, and a Camry. And it really looks like the Civic is really, really killing the other two, because we started at 30 miles to the gallon. If we started at 0, then yeah, the Honda Civic still is higher, but the differences now have become much less impressive. So this is a misleading way. Another thing to do, people will use pictures. In this case, if we look at airline passengers in 1984, U.S. Airlines reported carrying 345 million passengers. 2010, they carried 706 million passengers. So they've got this little airplane and this big airplane, but this big airplane looks to be about 4 times as big as this one. And the data are that this plane should only be twice as big, because it's about twice as many, a little bit over twice as many passengers. So this is a way that you can use pictographs to make things look different. And I've seen a number of these. Here's another way. If we plotted this on a scale of 0 to 800 million, it's much less impressive, and it gives you a better idea. This is still a big increase, but it's not nearly as much as we saw before. Okay, where are we? Quickly, I think we're done with this. All right, so let's go back to, do you have any questions, Jessica? You haven't interrupted me much. I know you've had to pay attention to to others, but that's all right.
No worries. I don't have any questions. Not yet.
Okay.
Mom, look, I made it.
Not yet. There was one question I had about the it was like way back in the beginning though. When we were talking about the presidential
Survey.
Yeah, the presidential survey with that Roosevelt's election.
Right.
How was his more effective? What did he use? The second guy that started with the G, Jalopia?
Oh yeah, Gallup.
What did he
Gallup.
use?
He did a.
How did he,
go ahead.
no, you go ahead.
Okay.
How did he use his sampling method?
He collected his sampling. Let me see if I can get back to it quickly here. I may have gone past it already.
What was his name?
His name was George Gallup. You've heard of Gallup polls. He was the founder of the Gallup polling organization. But what he did was, instead of taking a group that was fairly uniform, they were wealthier because they could afford cars, homes, telephones, and they could afford to to subscribe to the Literary Digest. So they tended to be wealthier. The wealthier people tended to be, let's see if I'm trying to find, wealthier people tend to be Republicans, just to be
I think it's on page 8.
Pardon? Page 8?
I think it's on page 8.
Got it. We'll go back there. 4, 5, 6, 7, 8. You got it. Page 8. Thank you. Anyway, what Gallup did was that he attained a sample that was more diverse demographically. He went and sampled likely voters who were of all different classes of economics, and tended to probably gender and race as well, because
So was his voluntary sample source, or was how
well,
was his non-bias?
his let's go back and say, I'll say it was relatively non-biased. As I said earlier, you cannot force a person to participate in a survey. So there is a voluntary component to all of these. So, but what it is when the Literary Digest went to their subscribers, they were largely well-educated, wealthy people who would buy the Literary Digest. That was considered an intellectual magazine of the time that people used. But also they were car owners and had telephones, both of which were not real common back in 1936. People couldn't afford cars. Most of them couldn't afford a telephone. So by definition, they tended to be better off in a higher economic bracket, which tended to mean that they were going to be Republican, meaning they were more likely to vote for the Republican alternative, which was Landon. Whereas Gallup went to a broader range of demographics. Certainly he had some people in there that were wealthy Republicans, but he also had people who were, laborers, and people who did not have money, and tended to be more aligned with the Democratic Party. So he probably ended up with a much more evenly distributed sample that he drew from, whereas the sample from the Literary Digest, by choosing people with money, tended to be smaller. People with money like the status quo. They don't want to see these guys coming in and changing things. So, and that was as true then as it is now. So by nature, the Literary Digest did a job that was almost totally convenience, because they were dealing with their subscribers. So
how does
easy.
How does the census reach each household? Is it through the mail? And is that also how Gallup reached his different demographics? Was it through the mail?
I don't know the exact details of how Gallup did it, but I think they used a mix of mail and actually going out and talking to people. At that time, mails, again, a mailed response back required a stamp, and that was money that a lot of people didn't have at that time. Yeah. So I think it was probably a mix, definitely the Literary Digest was a mail operation. They mailed out these 10 million requests. I'm impressed they got as many back as they did, but they did. So the sample that the Literary Digest did was a small cohort, whereas Gallup had bits and pieces of a large number of different demographic groups. Now, you asked about the census. They start with mail. You will get a mailed census. You'll be asked to send it back. Most of us, almost everyone sends them back. Anyone who doesn't, the Census Bureau has a group of workers that they hire to go out and visit the homes of people who have not responded by mail. So what we do, I did this one year, in fact, just for fun. And what I was doing was driving all over the mid-front range and halfway to Vail, going sometimes into some pretty remote locations and knocking on doors to try and get people to fill out the form. And then when I got someone that I talked to, then I'd take the form back. I'd fill out the form with them, help them fill it out, and then take it back to the office. If I could not get people to respond, and a lot of people didn't answer their doors. Sometimes I was pretty certain someone was home, but we didn't have any authority to do anything other than ring the doorbell or knock on the door. So I'd try 3 or 4 times, and then I'd turn it over to my superior, and they would send a federal officer, an officer of the Census Bureau, out to speak with the person. As a result, we probably had, this was 2010, so we probably had well over 99% of the households in the country, one way or another, responded. And again, if someone absolutely refuses,
how do you count the household?
yeah,
if they absolutely refuse it, how do they count?
The Census Bureau will note that household did not respond at all. So we do, as I said earlier, part of having your survey is how many people refused to participate. So that gives us, a small read on how how many people haven't participated, and it as I say, it usually is okay. As a census taker, I was considered a federal officer of some low level, federal employee. So I was given permission to go onto people's property and actually try to get them to talk. If someone, I only had one person who just absolutely refused. And so I said, well, okay, thank you very much. I'm going to tell you I have to turn over that information to my supervisor, and you may be hearing from someone later. And then I'd leave. So that's, it's a remarkable bureaucracy, and that last minute push is really kind of interesting. But when the census starts, they'll put out a call for people interested in being census taker. We had everyone from process servers to bakers on our team.
Wow.
Yeah. So it was,
That's
it was
cool.
fun. How
many questions are on the census?
There are 2 levels of census. There's a generally just a short demographic census, how many people, what's their age, birth dates, etc. And then there is a percentage of them that get a much longer form that asks questions like religion and ethnicity, and well, no, the ethnicity is on the other one because we collect those data, but things like religion and work and that sort of thing. So there is a broader, there is a long form, but not everybody gets it. So the short one is about a page, as I recall. The long form is 3 or 4. So
Is
yeah.
your sound going?
That's very interesting. Yeah.
Okay. So
What a cool job too. How long did that job last?
I think I was working for the Census Bureau for about 2 months.
Okay.
So might have been 3, but I think it was 2. But it was fun. As I said, I met a lot of nice people, so it was a lot of fun.
Yeah.
So anyway, this week, let's go ahead and get started on the discussion and the assignment, and we'll worry about and the assessment later on. We'll worry about in-class activity another time. Okay?
Okay.
Any
Yeah,
other
I get it.
questions?
No, I think that's it for now.
Good. Well,
Wait a minute.
sure.
One more question. Sorry.
No problem.
What are we doing for Zoom for on Thanksgiving? Are we gonna Zoom on Thanksgiving?
I don't envision that as a live Zoom. I may do a small recording to just to urge you to get the work done and maybe clarify any questions that I get asked. It'll be short because everybody'd rather do something else on Thanksgiving. But we do have a requirement to do that. So, but it will be a short one. And
Okay,
what I'll do is
awesome.
record
Cool.
it and just send you guys the link to the video, and you can do it at your leisure over the weekend. Okay.
Okay.
All
Awesome.
right.
Mhm.
Great. So, Kyle, I want you to watch this. Have watched this. When you have done so, send me an email. And there is a code word. Code word is Tokyo, Tokyo. Just send that to me to let me know you've watched, and try to get the work done. And I'll see you on Tuesday night. I hope. Weather better cooperate.
Yes.
Okay.
It
Well,
should.
nice talking with you, Jessica. Good to have you in class again, and I'll see you next week.
Yeah, definitely. Thank you, Mike, for everything. We'll see you next week.
Okay. Bye-bye. I'm going to stop the recording now.
Bye.